Hey guys, let me show you our lab setup for the first part of this lab. So what I have here is I have a candle, which I'm going to light, and then that is going to be our object. Here, I have a lens, right? We can look through that lens. So we have a lens there, and then what I can do, oops, let me adjust this, is we always measure the distance to our object from our object to our lens. So I can manipulate the distance to our object. Okay. What our responding variable is going to be is over here, I have a screen. So I can move my screen, but remember that we always measure the distance to our image from our lens to our screen over here. So right here I have my lens at about, let's just make it nice and easy to calculate. So I have it right here at 20, and then my screen is over here at 47. So although it's at 47, because this is at 20 here, then the distance to our image would be 27. So that's how we make that reading, right? So this one would be 20, and then this one would be 27. Okay, so let's take some measurements. So what I'm going to do is I'm going to shut the lights off, and we're going to take some measurements that you guys can record down. So when I'm at 20 here, what we'll see is that, yeah, I'll sort of put it along here. No matter where I go, I don't really get a nice image, right? If I go super far away, it starts to get a little bit closer. But what the problem is here is we might be right around our focal length. So what I'm going to do is I'm going to move this back a little bit. I'm going to start at about 27 there. Okay, so there we go. So my distance to my object is 27. And now what we're going to do is we're going to adjust this until we get a nice focused image. Ooh, that candle is big. So right about here, a little bit further. Sorry. I'm still not getting a focused image in here. So let me just move it back just a little bit. I'm going to move it to 28. There we go. Okay, so that'll be our first measurement. There we get a nice inverted image, and you can see that our candle is this way, but our image is inverted on the other side. So what we get is we get a real inverted image from doing this lab. Okay, so in terms of our measurements, so I got my first image right when my distance to my object was at 30. And then over here, the distance, I'm at about 98. But remember that this is at 30, this is at 98. So the distance to our image is going to be 68. Okay, so that's going to be our first measurement. Distance object 30, distance image 68. So what I'm going to do is I'm going to increase it a couple. When I increase it a couple, so I'm up to 32 for the distance to my object, I have to bring it in a little bit. There we go. I have to bring it in a little bit to get that focused image. So now I'm at, we can say, 94. So I've got that nice focused image. I'm at 94. This is at 32. So 94 minus 32 is going to be 62. Okay, and then I'm going to increase it a little bit more. So maybe I'll bring it to 35, and we'll try to find that focused image. Yeah, about there. That looks nice and focused to me. So we're at 35 for a distance to our object, and we're right at about 90. So 90 minus 35. So now the distance to our object, or image, sorry, is 55. So 35 and 55. Okay, so I'm going to increase it. Let's go 38 for the distance to our image. And then 38 for the distance to our image. Let me just move our candle a little bit to center that. And then, yeah, about there, we get that focused image. So here we're at 38. Here we're at 87. So 87 minus 38. What is that? 87 minus 38. We're at about 49. And right around this point, if I increase it, so I'm going to increase it to about 42, you can see that my image stays nice and focused at the same place at about 87, right? And it seems like, oh, nothing's changing, but that's not true, right? Because now I'm at 42, and this is still at 87, so if we go 87 minus 42, we end up getting 45. Okay, so let's increase it a little bit more. Let's increase it. So now I'm at 47. So the distance to my object is at 47. And it looks like I'm still good right around that 87 mark. So 87 minus 47. So when I'm at 47, the distance to my image is about 40. And now let's increase it. Let's bring it up to 52. So at 52, now my image has gone blurry, right? If I bring it closer, it gets even more blurry. But if I move it back a little bit, yeah, right about there, I'm at, yeah, I can say I'm at 90. So when I'm at 90, and this is at 52, so we go 90 minus 52, we get 38. So distance object 52, distance image 38. Sorry, 38, yeah. Okay, I'll increase it to, let's increase it to 58. So now I'm at distance to object is 58. And then, there we go. Yeah, and now I get a nice clear image at 94. So if I go 94 minus 58, I get 36. Okay, so 58 for our object and 36 for our image. And you notice how it keeps on getting smaller. Let's do one more. Let's bring it up to 65. And now my image has gone blurry, so my distance to object is 65. And then, yeah, right about there, I get that nice focused, inverted, smaller candle image. And I'm maxing it out right here. So I'm at 98. Oops, drop my camera there. So if my object is, my image is at 98 and my object is at 65, then looks like the distance to my image is 33. So distance to image is 33, distance to object is 65, and then we get that nice small image, right? So when I'm closer to my focal point, I get that big inverted image, and as I go further away, I get that inverted smaller image. Okay, so this is how you do the lab, and this is the data you can use to do this lab. Hey guys, let me show you part 2 of this lab with the diffraction grating. So let me show you my lab setup. So these are my, oops, camera's spinning. There we go. These are my different diffraction gratings. So these are the ones that I'm going to use. And I wrote them up here on the board. So I'm always going to do it in this order to make it easier for you. So 100 lines per millimeter, 300 lines per millimeter, 600 lines per millimeter, 530 lines per millimeter, 13,500 lines per inch and 1,000 lines per millimeter. That's what I'm going to do. Okay. Here I have my very technical setup. I have my laser pointer. I just need to hold it steady. So I just put it in there, and then I have the elastics wrapped around, which helps hold down the button. And then over here, I have a ruler taped on there. And I also need to measure my length. So one of my controlled variables is going to be my length. So I measured from my board to the end of my books here is exactly 1 millimeter. And it's always measured from the diffraction grating. So when I hold it up, I'm going to make sure to always hold at the end of the books here. That's what I'm going to do, because that's exactly 1 meter. So my length is controlled, that's 1 meter, right? Here I have my laser pointer. This is blue light that I'm going to start off with. And I'm always going to measure to the first N. That's another one of my controlled variables. So the fact that this is blue, I'm always going to measure to my first N, and the fact that it's 1 meter, those are my controlled variables for this experiment. Okay, so let's do it. Let's take some measurements. Let's try it out. Okay, here we go. So this is for the blue laser. So we'll start off with 100 lines per millimeter. So we're at 4 centimeters for our first one. And then we'll go to 200 lines per millimeter. So we're at 12 centimeters for our first one. And then we'll go to 600 lines per millimeter. And we're at 25 centimeters for the first one. Our next diffraction grating is 530 lines per millimeter. Just got it facing the wrong way. So 530 sends us to 22 centimeters. And then 13,500, this one's a cool one that shows all of them, but so it doesn't matter which way you do it. So if we measure the first one, it looks to be about 9 centimeters. So 9 centimeters to the first one. And then our last one, 1,000 lines per millimeter, looks to be 48 centimeters. So 1,000 lines per millimeter is 48 centimeters. So here is our green laser. So when we're using 100 lines per millimeter. Our first one appears at about 5 centimeters. 300 lines per millimeter, 16. And then 600 lines per millimeter, we get our first one at 34. This is 530 lines per millimeter. We get it at 30. And then our weird one, we get it at 10 centimeters. And then our 1,000 lines per millimeter, we get it at 62 centimeters. Here's our red laser. Our 100, our first one is at 7. For 300, it's at 20. And for 600, it's at 47. 530 lines per millimeter. We're at 37. Our 13,500 lines per millimeter. We're at 13. And then our last one, our 1,000 lines per millimeter, we're at 92.